Well, thank you everybody for joining us today. Let's go ahead and get started. Just a few brief housekeeping items. You should see a chat function on your screen, and if you have any questions, you're welcome to post them there. There's also a Q&A function you can use, and we may do a couple of polls as we go through the session, and I'll ask you just to provide your reactions and your feedback through the Q&A functions of the Goldcast system. With that, let's go ahead and get into it. What we're talking about today is our Healthy Building Discovery Workshop. And we're hoping in the course of the next hour or so to give you a good overview. My name is Uri Kogan. I lead product marketing here at R0. And so let's take a quick look at that agenda. Our agenda today is really going to be to try to get you to kind of walk you through four ideas. First of all, I want to show you kind of how much upward pressure there is on the cost of running a building, as well as the cost of upgrading it in order to lower the operating costs. It's a real challenge. Then I'm going to spend the majority of the time explaining how you can escape the pressure, the pressure that you're under to improve the performance of your building with low-cost ways to run the systems that you already have in a smarter way. Then I'm going to show you how some of those same strategies that can help you improve the way your building is run can also deliver productivity improvements. And I'll explain how some of those improvements can then deliver even more cost and time savings. So my hope is that you're going to take away from this workshop a sense that rather than kind of a vicious cycle or a doom loop where the pressure only grows, you can actually create a virtuous cycle where small improvements that you make can compound on one another, and each improvement unlocks the next. So let's begin by talking about how meeting ventilation and indoor air quality standards is getting more and more expensive. The reality is that building owners and managers are facing a triple whammy that's raising the cost of meeting building ventilation standards. And that triple whammy is the rising cost of energy itself, the rising cost of HVAC systems and labor to install them, and the demand for higher indoor air quality. Let's take a look at each of those. Over the past 10 years, as overall price levels for producers have gone up about 80%, which is what you can see here in this black line, electricity prices, which are the dotted blue dash, the blue dash line, electricity prices have generally kept roughly in pace with overall producer inflation. Now, there are some locations like San Francisco, where I live, where they've unfortunately gone up quite a bit more, especially in the last couple of years. But on a nationwide basis, they've kept roughly par with inflation. Now, on the natural gas side, since the shale oil boom began in 2008, natural gas prices, you can clearly see kind of get broken apart from inflation. Get my pointer in the right spot here, and start to underperform inflation in terms of prices, up until the last couple of years when there was a huge spike. And so even though natural gas prices are a bit lower, at least, or increasing a little bit less quickly than overall prices, there is a lot of volatility. And that volatility makes it harder to budget for heating, cooking, and other gas-powered energy uses. Now, on the other hand, the fraction of energy that commercial buildings are getting from electricity versus natural gas is actually going up. So what you can see on this chart is over the last 40 plus years, the fraction of energy that's coming from different sources into commercial buildings. And you can see that, overall electricity's share has been trending up, especially since the mid 1990s. you can see that starting around here in 1995, the share from electricity starts to go up, and it's gone up from about 50 to about 60% as of 2018. And I should point out that commercial buildings in this definition from the US government includes a very wide variety of buildings. It's not just commercial office space, it's healthcare, it's education, it's religious buildings, lodging, warehouses. We'll see that a little bit more in a minute. Now, on top of higher energy costs, the cost of upgrading HVAC is also going up faster than inflation. So here you can see the same black line, the same black line representing overall inflation. And you can see that the cost of HVAC equipment and refrigeration equipment was roughly similar until the last couple of years, where it has significantly outpaced overall inflation. And the same thing is happening on the labor side, where the overall inflation for employment costs is this lower dotted line. And for commercial plumbing, heating, and air conditioning contractors, it's the green dotted line that is moving up faster than the overall employment cost index. So if you look at this holistically, the cost of equipment is outpacing inflation now by about 37% as of the last data in November of 2023. And the cost of labor is outpacing overall cost of labor by about 20%. So it's clearly becoming more and more expensive overall. We all know that there's been a lot of inflation recently. It's becoming more and more expensive to do lots of things in this economy. But this is especially true for electricity. It's especially true for HVAC equipment. It's especially true for HVAC labor. And then the third reason that it's getting more expensive to meet these new requirements is that the requirements themselves are getting stricter. There's a growing focus on indoor air quality. And, thank goodness for that, because that helps us all be healthier. But unfortunately, it's not free. So this chart shows you what's going on with ventilation standards from the American Society of Heating, Refrigeration, and Air Conditioning Engineers. This is just one example, but it's a really clean and easy illustrative example of how these standards are changing. Last year, first of all, ASHRAE has two predominant standards for ventilation. One is 62.1, which is for commercial buildings in general. The other is 170, which is for healthcare facilities specifically. And last year, they put out a new standard that says, hey, when there is increased risk of infection, as there has been, of course, in the last few years, and as we're all going through right now in these winter months, when there's increased risk for infection, you want to boost ventilation even more. And how much is really what this chart is showing you. So what you can see is that in healthcare settings, on the left-hand side here, in an exam room, you want to increase from 6 to 8. In a patient room, from 4 to 24. That's a 6x increase. In a waiting room, from 12, which is already quite high, up to 40. That's a very, very large number of air exchanges every hour that you need to achieve to maintain a healthy environment for all the people that may be sitting in that waiting room. The overall air exchanges are not quite as dramatic in other settings, but nevertheless, the changes are quite high, which means that you have to get from kind of your pre-existing approach to a much, much higher approach when you have higher infection risk. And so that's going to require really rethinking how you're approaching your ventilation. So in education, for example, you can see a roughly 2.5 to 3x increase. In offices, similarly. And then we have a couple of other examples here from a public assembly and religious buildings as well. Now, this is not just about ASHRAE standards. The CDC also came out with a recommendation last year for 5 air changes per hour minimum. The Lancet recommends 6 or more. And there are other high-performance building standards like LEED, Fitwel, WELL. They're all increasingly emphasizing the importance of ventilation and indoor air quality. LEED version 5, for example, was introduced in beta last year, and they have given now increased points for IAQ monitoring, for indoor air quality monitoring. They used to provide 4 points if you did periodic monitoring. Now, if you do continuous monitoring in real time, you can get up to 10 points toward a LEED certification. LEED also added a recommendation to use MERV 13 filters. And if you have moved from lower quality to higher quality filters in your building, you already know that there's an energy penalty to be paid for that. So not only the filters themselves are more expensive, but the cost of running your HVAC and pushing air through those filters is generally a little bit higher as well. And so all in all, the fact that indoor air quality standards have gone up is an important driver in the cost of meeting those standards, in addition to the cost of labor, the cost of equipment, and the cost of energy going up. So all of that really does sound like a doom loop, like a vicious cycle that is going to really harm folks' budgets. So what do you do about it? The good news is you don't have to live within that kind of a framework. It is possible to do something about it, and that's what we're going to be talking about next. Essentially, smarter management of the systems that you already have in place can achieve really significant savings. So let's take a look, first of all, at a variety of different commercial buildings. You can see on this chart the fraction of energy use across every commercial building type that's represented here, the fraction that's going to space heating, which is the bottom part of each chart, the fraction that's going to cooling, to ventilation, and lighting. And you can see that toward the left-hand side of the chart, public assembly buildings, retail, outpatient healthcare, education, offices, etc., roughly around here and to the left, 70% or more of the energy is being used in the HVAC system and in lighting. On the other hand, if you look at the right-hand side of this chart, food service, food sales, refrigerated warehouses, a much smaller percentage of the energy use is going into HVAC and lighting. So what we're going to be talking about over the next couple of slides is really strategies about being more sophisticated in your HVAC and your lighting. So these strategies are particularly valuable if you're talking about the kinds of buildings that are toward the left-hand side of the chart, less valuable if you're talking about the kinds of buildings that are on the right-hand side. So keep that in mind. Now, I'm not going to talk about every single building type because we don't have the time, but I will be talking a little bit about office buildings and inpatient healthcare, about hospitals. And so if you, for example, are here from a senior care or nursing home, or you're here from a school, keep in mind that the percentages that might apply to you might be a little bit different. But broadly speaking, you're using about the same amount of energy as offices and nursing homes in terms of how it's divided up into different kinds of uses. So the same strategies are going to apply, albeit with a little bit, varying results. So let's talk about offices first. So across office buildings in the US, energy is divided up, as you can see on the left. This is just expanding the chart that we had on the previous slide. So it's 30% space heating, 7% air conditioning, 20% lighting, and 20% ventilation and 12% lighting. So all in all, that adds up to about 69% of energy use in the HVAC system and in lighting. And we want to talk about 5 really great strategies that you can use to shrink all or part of that 69%. The first one is in some ways the simplest. Just turn down the HVAC and the lighting when people are not in your space. Of course, many buildings are already doing some version of this, but many others don't, or they don't do it precisely. So how many of you have seen into an office building at night when the lights are blazing and no one's around? In many cases, buildings might use timers that were set years ago when building usage was different. At some point, somebody needed to be in the office late and the system was overridden, but maybe it was never adjusted back. And these days, many offices are only partially occupied due to hybrid working staff. And that occupancy dynamic, of course, was never considered when people were setting the rules and the parameters for these systems in a pre-pandemic Monday to Friday, 9 to 5 kind of world. Now, in many cases, companies have consolidated the staff that are in the office to fewer floors or spaces. And that means that the spaces that are staying empty can also be turned down. But in order to manage HVAC and lighting based on occupancy, in a precise way, in a way that reflects what's happening today, what's happening this afternoon versus tomorrow, you actually need to know that occupancy in real time. And you need to be able to send a signal to the HVAC and the lighting systems accordingly. And in order to do that, you need to be measuring that. You need a network of sensors, and that can be expensive to install. That can be expensive to wire, to program. And the software to smartly connect it to the building systems is also sometimes complex. If the sensors are battery powered, you have an extra hassle of replacing batteries, all on an overburdened maintenance staff. But maybe it doesn't have to be that messy, right? At R0, we make battery-powered occupancy sensors, and they run for 5 years without maintenance, and they're wireless. So installing them is really just as easy as some double-sided tape and sticking them to a wall. And because that battery lasts a long time, you don't have to worry about replacing it. The software that we make helps you do this adjustments dynamically and automatically. So it is possible to achieve really dramatic occupancy-based lighting and HVAC savings without a huge investment, without a huge hassle. Let's look at the second strategy. This one applies specifically when infection risk is higher, and as it actually is in much of the country at the moment, and you want to run your building at an even higher level of ventilation or clean air in order to meet the ASHRAE 241 standard, or just to ensure that extra level of safety for everybody who's occupying your space. So one way to do that is to bump up the amount of outdoor air that you're taking in. But if you do that, of course, you're going to be running the ventilation more, and that fresh air has to be heated or cooled depending on the temperature. If it isn't 68 degrees outside, you're going to have to heat or cool it. Or you can deliver that extra boost of air changes with ultraviolet, with upper room ultraviolet germicidal disinfection instead of ventilation. And that has the added benefit of cleaning the air directly in the room, which is where most of those infections spread. And we'll talk a little bit more about that a little bit later. For now, I just wanted to point out that kind of approach can deliver significant energy savings as compared to increased outdoor air ventilation. The third strategy I want to talk about is about avoiding the overuse of outside air when your indoor air quality is sufficient. So the existing ASHRAE standards for ventilation that are embedded in building codes and sustainable building programs like LEED, they offer several different approaches to figuring out how much ventilation you need. The most common is based on occupancy, and usually people use that to calculate the size and scope of their system when they build the building, and they never come back and adjust it dynamically, which is what we talked about in the first strategy. But there's another approach you can use to calculate the amount of ventilation required, which is based on an indoor air quality measurement. In order to do that, of course, you need to be measuring it. And to oversimplify this a bit, many buildings are actually often over-ventilating relative to acceptable indoor air quality. And so when you're in a situation like that, if you can reduce the ventilation, of course, and reduce the amount of heating and cooling you need to do of that outside air, again, you're going to deliver significant savings. Now, in order to do this, you have to be measuring indoor air quality continuously and adjusting the HVAC. And as I already mentioned, if you do that, that also will give you additional LEED points. The fourth strategy is a bit more conventional because it relies on changing physical equipment, specifically filters. So lots of folks have been paying close attention to filtration in the last few years because many building owners and managers have responded to the pandemic by increasing their filters from MERV 8 to 13 or higher. That often ends up creating an energy penalty because you have to push air harder to get through the filter. But there are actually alternative technologies that can deliver an even higher rate of particulate capture. Some of these systems use electric charges to condition the particles in the air with a negative or a positive charge so that they glom onto one another, which makes them bigger, which makes them easier to push through the air and get attached to the filter. And that kind of approach doesn't require as much energy as just having a finer mesh filter, and it can also deliver even higher air quality, sometimes even exceeding HEPA level filtration. And because it doesn't require as much ventilation energy to push through, it saves you money on the ventilation system. And then the last strategy I want to mention is around lighting. So if you have available natural light and you're measuring that and you're controlling your lighting accordingly, you don't need to have the lights on all the time. I don't have the lights on here in my room where I'm working today because I have plenty of lighting from the window here in front of me. So all of these strategies have some very, very important things in common. None of them require that you install a new HVAC system. None of them require a new air handler. None of them require a new heat pump. All of these really expensive upgrades that, of course, are where people's head goes to first when they're thinking about how can I save energy in my building. None of them require looking at the envelope of the building, the windows, the insulation, the roofing. None of them require a building permit or complex engineering studies or designs. All of these are about just using low-cost sensing and software to run the system you already have more intelligently. And in a couple cases, having smarter filters or in-room UV disinfection products. But compared to the cost of an actual HVAC upgrade or a lighting upgrade or new windows, new insulation, it's dramatically easier. It's faster to implement. It's less expensive, and you're going to see a much, much faster ROI. Also, importantly, you can start and apply these strategies at a sub-building scale. You don't have to do this across an entire building like you might if you're doing an HVAC retrofit. And that means that you can start at a small scale, realize some savings, reinvest those savings to expand the project into other areas in your building. That means that you're getting payback right from the get-go. It's early and continuous. And when you can start to generate savings that pay for themselves and pay for additional projects, that's when you go from a kind of doom loop to a virtuous cycle. And that's really at the heart of the narrative of kind of our recommendation today. Now let's take a quick look also at hospitals. So hospitals, it's a very similar story. I'm not going to go into the same level of detail here at all. Just to say that, of course, hospitals are a bit different than office buildings. Most importantly, hospitals actually use about 3 times as much energy for every square foot as an office building. So that means if you can save 1% in energy, you're generating 3 times more dollars of savings than you would in an equivalently sized office building. But the way that energy is used is also a bit different. We saw in the office example, if I just go back real quick, that only 31% of the energy is in that other bucket. In hospitals, it's about 40% because hospitals are also feeding everybody. Hospitals have a lot of hot water usage. Everybody needs to take a shower or bath or get bathed while they're in the hospital. Hospitals have a lot of big equipment like MRI machines that take up a fair bit of energy. So the other category here is a bit bigger. The HVAC and lighting category is a bit smaller, but nevertheless, a lot of the same ideas apply. Another important difference I want to acknowledge that people think of is, how can I turn down the lights and the HVAC when people are not in a space? This first strategy. Does that make any sense in a hospital? A hospital is a 24/7 operation. But the reality is that there's a bigger opportunity here than you might think of at first blush, because in a typical hospital, most of the space, most of the square footage is not medical inpatient care. Most of it is administrative areas or clinical spaces that aren't actually used all of the time. So there is still a significant opportunity in those kinds of spaces. So with that, let's take a quick poll. I want to ask you guys a handful of questions. I want to understand whether energy savings is a top 3 priority for your role, whether it is a top 3 priority for your organization, and also if your organization has sustainability goals. So I'd appreciate it if you could take, 5 or 10 seconds and just answer those 3 questions, either in the chat or the Q&A. It looks like we've had a few answers, so I appreciate you all taking the time. It looks like there are a handful of you for whom it is a priority in your role, a few more for whom the organization is focused on it, and most of you have said that your organization does have sustainability goals. So I appreciate that feedback. With that, I want to turn now to a really important part of the conversation, which is, let's assume that you've bought into my premise that low-cost sensing and smart software can deliver these big energy savings. And let's also assume that you've put these sensors in place. Is there anything else that we can do with this data and with the value of what we're learning from these sensors? The answer is absolutely. There's so much more value to be gained. And if you think about it, again, in the framework of the whole conversation, we've built this, virtuous cycle of energy savings with low-cost sensing. We save a little bit, we expand, we save more, we expand. This takes that virtuous cycle and expands it even further by talking about, well, what else can we do with this data and how else can it pay off for our organization? So the first thing to mention here is just having the assurance of real-time monitoring. If you're measuring occupancy to drive how you're using ventilation and HVAC dynamically, you're also going to learn about utilization, about how much time people are spending at their desk or in a particular area. You're going to learn about vacancy rates of the spaces that you're measuring. And if you have the right analytics in place, that can help you do smarter space planning. Maybe you have a lot of empty desks, but never enough phone booths or conference rooms. Maybe the conference rooms you have are often occupied by 1 or 2 people and others on Zoom who are underutilizing that space. If you're measuring occupancy, you're going to know, so you can adjust your furniture or your space layouts to serve your organization better. If they allow you to consolidate your real estate footprint, the energy savings are obvious. The second area is smarter cleaning. In a clinical setting, your environmental services team is likely applying the same degree of care and attention to disinfecting exam rooms and waiting areas, whether they've been busy that day or not. That doesn't make sense. Smarter cleaning lets your team spend their time where it makes the biggest difference. In an office setting, the same principle applies. The third way this data can create value is measuring occupancy at a bigger scale, across the whole floor, building, campus, or even your entire real estate portfolio. Just a handful of sensors at every entrance and exit can provide the analytics to understand the flow of people in your spaces without having to integrate complex, hard-to-process data from badge swipes. In the clinical setting, in a hospital setting, similarly, many hospitals are concerned about overcrowding in the emergency room waiting area or other parts of the hospital. And they try to use data on how many patients are arriving and checking in to try to monitor and understand that. Integrating that kind of data, which has a lot of HIPAA compliance issues, into a system that allows you to monitor that in real time is really, really hard. If you can put a few sensors in place in a waiting room to understand how many people are there, put a few sensors in place in some of the typical pathways that people take, you're going to understand, when do I have overcrowding in this space and need to move people to a different space? You're also going to understand, are there certain places in the hospital where people are consistently getting lost and end up wasting time of my nursing staff, which is precious. There aren't enough nurses, wasting time of my nursing staff to help direct them. So there are benefits from the same kind of data all through office and hospital spaces. The last area where you can benefit is using bookable space in a smarter way. Any of us who have worked in an office have had the experience of needing a conference room and seeing none available to book in the system, and finding some with just a backpack, or maybe in some cases no one and nothing at all that have been booked. But your calendar booking system doesn't know if anybody's actually shown up for the meeting. With occupancy sensing and integration into calendaring systems, you can release those ghost bookings so that that precious conference room space doesn't go to waste. And it's easy to get started. In order for this whole premise of this virtuous cycle to make sense, it has to be easy to get going. As I've already mentioned, it doesn't require major upgrades or construction delays. That's usually the biggest barrier to getting moving. If you have simple sensors and software, you can get a long way very easily. At R0, we believe technology should make it possible to generate that financial return almost immediately. We believe that technology should enable your team, not frustrate your team. So we design software that is easy to use and sensors that don't require maintenance or frequent battery replacement. And we build on open standards with a modular system, so you're never stuck with data that you can't use, or a system full of proprietary protocols that locks you into buying HVAC or lighting or other major building systems from the same vendor. Now, I want to take this whole virtuous cycle idea to yet another level, kind of a third degree. What is the benefit of a healthier building, and what does that save you? And here we're going to look really briefly at how a healthier building can save both in a hospital setting from a clinical point of view, as well as for the cleaning staff. So first off, the direct cost of treating a surgical site infection is really high. It's estimated at over $28,000 a year by the Federal Agency for Healthcare Quality Research. And that study was done 6 years ago on data that's even older. So it's a safe bet that the cost of treating a surgical site infection is now well over $28,000 a year. And in a typical hospital, there are about 20-some surgical site infections for every operating room every year. If you can reduce those by 30% by having a more disinfected environment, the average hospital would save 3 to 4 surgical site infections for every operating room per year. And that's a savings of about $100,000 in unreimbursed care. Not to mention, of course, the patients themselves being healthier and having a better outcome. If we look at the wards and patient rooms, C. diff cases cost even more to treat than SSIs. The latest data is $34,000 per case, and they occur in about 1%, a little bit less than 1% of patients. Studies have shown that terminal room disinfection with ultraviolet can lower those rates by 30%. That can work out to a savings of about $2,000 per hospital bed per year. That's pretty significant. Beyond the benefit to patient care, the cost of surface and air disinfection is really high, and every type of organization can save significantly with a smarter approach. I want to give you examples from hospitals, education, and senior care. In a hospital context, we've already talked about smarter cleaning earlier. But if you combine smarter cleaning and directing your team to the right places and ultraviolet disinfection, overstretched EVS teams can really prioritize non-clinical spaces and save time. Most of the space in the hospital isn't clinical. Hallways, nurses' stations, cafeterias, administrative spaces, all of those areas need to be disinfected, and UVC can reduce the burden on the staff. Second, as we already talked about with terminal room disinfection, we talked about it from the patient point of view and C. diff. It's a critical EVS function to do it. Many teams are using electrostatic spraying. They're suiting up, they're laboriously cleaning each room. The teams that use UVC instead of electrostatic spraying are seeing much more effective and time savings in the context of that work. And that's generating really dramatic savings. Combining those two, you can save in a typical hospital almost $800,000 on manual disinfection efforts. In the education space, let's take a typical 900 student school. High risk spaces where there's the most gathering, those are classrooms, cafeterias, gyms, bathrooms, can be protected by about can save about $80,000 and see a payback time as short as 14 months by implementing ultraviolet disinfection. Doing that can reduce the workload for overstretched custodial staff while reducing microbial loads by over 99%, preventing odor and the spread of mold and mildew. And in senior care, in a typical 100-bed facility, again, you can protect those spaces for about $22,000 while saving $50,000. That can deliver a payback time as short as 5 months on the cost of manual cleaning. Think about dining rooms, activity rooms, physical therapy and fitness areas. If you can reduce the workload on your overstretched custodial staff while reducing those microbial loads by 99% or more and preventing odors, it's all a huge, huge benefit to your team. I just want to wrap up real quick by highlighting the fact that R0 has a lot of experience working with a really wide variety of organizations to help them create high-performance buildings that save money and make for more productive occupants. I hope that some of what I've shared resonates with you and your goals and can help you if you feel like you're kind of trapped in a vicious cycle where the costs are only going up as expectations are going up as well, and turn that into a positive and virtuous cycle of savings, of improvement, of healthier and healthier spaces for everybody who's occupying them. Now with that, I want to just wrap up and head straight to questions. I think we'll skip this poll, and for the sake of time, we'll jump right to your questions. So I would love to hear any questions that you have. Let me open up the question interface. And please go ahead and ask anything you like. I'll give you a minute to think. So one question that has come up is about how some of this ultraviolet disinfection works. So let me quickly touch on that. Let me reshare. And I'll walk you through that real quick. Whoops. Okay, so how ultraviolet disinfection works. So there's a couple of different products, but let's focus on the upper room one. So this is an R0 beam. And what R0 beam does, actually, this is an even easier to understand graphic. It sits on the wall and it projects UV light across the upper part of the room with LEDs. And that UV light disinfects the air in that upper part of the room. And as the airflow turns over in the room, because of our breathing, because of any other ventilation that's going on in the room, the air in the room is going to pass through that disinfection zone and get disinfected. Beam uses UV light that is 265 nanometers, which is extremely germicidal, but also not safe to project on people directly, which is why it is used in the upper part of a room. but it is able to generate an enormous amount of disinfection because it really is cleaning a very large volume of the air in the room. In fact, if a room is bigger, has higher ceilings, that the area above the beam is going to be a larger proportion of the room. So the amount of disinfection power actually grows in that situation. Let me see if there are any other questions. It looks like another question that's come in is, how can I use the data from your sensors to help my cleaning strategy? Okay, that's a great one. So I actually have a slide here on that really kind of explains this in the hospital context, but the office context is very similar. So what you can see on the left is a mock-up of a floor plan of a building where we are measuring occupancy in every room over the course of the day. And so you can see that there are certain rooms that are getting a lot of use, and there are other rooms that are getting very little. And as a consequence, your cleaning team can know which rooms they should prioritize, which rooms they should spend time on, which rooms maybe don't need to be cleaned at all because no one's been in them. One example I heard from an EVS leader in a large Midwestern hospital is that in their clinical spaces, certain rooms are assigned to a given doctor. If that doctor's on vacation that week, no one is using those rooms. But unless somebody tells the EVS team, they're not going to know. They're still going to come in and disinfect and so on. And so if you can just identify where people have been, you can prioritize. The middle chart here shows that if you're going further than that and using ultraviolet disinfection in those spaces, you can validate as an EVS leader that ultraviolet disinfection cycle has actually run in a particular space. This is in the case where you're using like a mobile tower disinfection device that somebody has to wheel into the room, turn on for a few minutes, and then wheel out. Unless you have a way to monitor and measure that dose was delivered in that room, you're basically taking it on faith that room was disinfected. But this helps you validate that and assure that you're cleaning the spaces you need to be cleaning. And then, of course, if you measure the same bioburden over a longer period of time, over the course of a month or a few months, you'll see that on a more continuous basis, certain spaces are getting the most use. And those are spaces that are going to be good candidates to install a continuous disinfection product like the Beam that we just talked about, such that you always have disinfected air throughout the day. You're not just waiting for a disinfection cycle at the end of the day or a few times per day, but anybody who's using that space at any time has a much greater assurance that the air that they're breathing is disinfected. So those are the kind of the simple ways to apply this smarter cleaning approach if you have good occupancy data. Hopefully that helps. Another question that's come in is, how is the Beam different from in-duct ultraviolet? So the Beam, as I said, is a device that you mount on the wall in the room. In-duct UV is often, as implied by the name, put in the air conditioning duct. The most common reason, actually, that people use in-duct ultraviolet light is to make sure that the condenser coils in their air conditioner and heater are not getting moldy or mildewy. So this is because obviously if that happens, then that mold or mildew is getting transmitted across all of the space that duct system serves. That's certainly a valid and appropriate use case. What we offer is in-room disinfection. And it turns out, especially with COVID, but also for other pathogens, most of the transmission tends to happen in the room rather than through the HVAC system. And so cleaning the air in the room when somebody else is ill or was recently in the room and was ill is actually more effective and more efficacious in preventing the spread of that infection than doing it through the air ducts. The second thing is, as we go back, if we go back to what we were showing earlier in terms of some of these strategies, if you need to run the ventilation in order to clean the air, you're running the ventilation, right? You're going to be using that 20% of energy in this case in an office building. If you want to preserve the health of that or disinfect that space without running the ventilation, cleaning the air directly in the room with a beam is a much, much more energy efficient approach. The beam it's a light. It's an LED light that's shining in your room. We all know that LED lights are extremely energy efficient. The beam is very powerful, but it uses about the same energy as a laptop. It's not using nearly as much energy as running the ventilation system in a building. So it makes a big difference from an energy savings point of view, as well as the effectiveness point of view. I think that is the last question. So I thank you very much for your time and attention. And I'm happy to, if you think of other questions or you want to get in touch, I'm happy to hear from you and continue the conversation. And I appreciate so much your time today and your attention. And I wish you all a wonderful rest of your week.